Wow. That's how I'm going to start my podcast. Something gets thrown at me. Okay, cool. Guess we know how this day's going to go. All right, so what we're going to do today, guys, is do kind of a quick exam review. Go over the key concepts. I'll tell you, give you some ideas of how I'm going to ask the questions. Okay, that kind of thing. So that's where we'll be headed today. Okay, and then you'll have some time to obviously work on the review sheet. Okay, and ask questions if you have them. All right, so first thing we went over in this unit, okay, has to do with climate. Now, the things you need to know about climate. The components of climate, and there are 4 of them: temperature, precipitation, light, and wind. Okay, but also, and probably even more importantly, the factors that affect climate, because we did a whole thing with the climatogram activity about investigating which factors were indeed most important, okay, for at least Canadian cities. All right, so we need to remember also some of the factors. Okay, the way I'm probably going to ask you about this would be some multiple choice. Okay, there'll be some stuff in there like, which of the following is not a component of climate, and there'd be a multiple choice, or I could, in the written response, give you a location, okay, with a map, okay, something that you would know or would be at least familiar with, and say, describe the factors that would affect climate for this location, and tell me how they would affect the components of climate, right? So if I asked you about, let's say, Cairo in Egypt, okay, you would say, okay, well, the factors that would most affect Cairo would be that it's equatorial. Its latitude means it's close to the equator, which means it's going to get the same amount of light all year long, and it's going to get high intensity light. So I've named a factor and the main component that it affects. Okay, then I would say, it's not really close to any major bodies of water, and any winds that are coming there make it quite dry. Okay, so I would be mentioning a little bit about wind patterns and a little bit about proximity to oceans or lack thereof. Okay, and then anything else I could think of and talk about what the weather or the climate in Cairo would be like. Everyone follow that? I wouldn't pick one like that. I'd probably pick a Canadian city that you'd be more familiar with. Okay, so that's the kind of thing I would ask there. It tells me if you understand and know the components of climate and the factors that affect them. Okay, second thing we went over, climatograms. Okay, and I've said to you a few times, the climatograms is going to be part of the written response. I'm going to put one on there, and you have to tell me which of the biomes we went over it is likely matched up with, and explain. Okay, so you'd look at it and talk about what the shape of the temperature line looks like. Is it a bell curve? Is it a line? Okay, where is that bell curve if it's a bell curve? Look at the precipitation bars. Are they really low? Are they really high? Are they even all the way across? Is there a wet time and a dry time? And based on all of that, okay, so you kind of analyze it on paper. Okay, tell me all those things, and then say this seems to fit with the whatever biome. Okay, because this biome has these features. Right, so an explanation, something like that. Questions there? Right, so that's obviously going to be a written response question. Okay, the third thing we went over is energy transfers on Earth, and it was probably the longest lesson, and it's the one that I told you has the most practical application type stuff associated with it. Okay, so certainly we need to know how energy is transferred within the 3 parts of the Earth we talked about: the atmosphere, the lithosphere, and the hydrosphere. Now, which one of these did we say was most important for energy transfers? The atmosphere. Okay, so this is the one you probably would want to talk about the most if there was a question about that, because within the atmosphere we capture radiation. Okay, there's convection going on. The atmosphere is always moving. Okay, that's what wind is. The jet stream is also in there. Okay, we've got, that latent heat can move from the hydrosphere to the atmosphere and then be transported, okay, to more northerly latitudes, and that can bring a lot of energy from equatorial areas. Being able to explain those kinds of things would certainly be important. Okay, with regards to the lithosphere, we said it was the least important, okay, in terms of transferring energy, but it is important in terms of the conversion of energy. Okay, albedo determines how much energy it absorbs. If it's a really high albedo like snow, it's very reflective. If it's, obsidian, which is black volcanic rock, it would have a very low albedo and absorb a lot of heat. Okay, so it's absorbing radiation based on albedo. It transfers energy by conduction, which is why it's not a big part of transferring energy. Okay, but the most important thing about the lithosphere is that that's where plants live. Okay, and the bulk of our conversion of energy from light to chemical energy by photosynthesis is done there. Okay, and then the hydrosphere, I mean, yes, it can absorb, again, a lot of radiation, so radiation is kind of part of all of them. Okay, there is some convection, that would be ocean currents, but the hydrosphere is basically the source of latent heat. Okay, that's where the water that becomes water vapor comes from. Okay, so essentially just being able to understand that. That would be probably a lot of multiple choice type stuff, at least for that part. Okay, now there's three things that can happen to energy when it encounters any place on Earth. What are they? It can be absorbed, reflected, or converted. Okay, and the conversion is photosynthesis. Okay, so that's the next thing. You might be asked about that, maybe even in a written response kind of question. Okay, explain what would happen to sunlight when it hits someplace on Earth. Okay, and you'd have to tell me. So if it's being absorbed, then there's going to be an increase in energy, and that means an increase in temperature because it'll be kinetic thermal energy. Okay, if it's absorbed, it could also be being absorbed and then being turned into latent heat. Okay, that could also be part of what goes on there. Right? It could be reflected, and that means that there's basically no change in temperature because it's just bouncing right off. Okay, or it could be absorbed. Sorry, I mean we already said absorbed. It could be converted by photosynthesis, and that changes sunlight into food energy, and that's where all food chains start. Okay, so that's obviously a very important part of what happens to light. Okay. Now, also within this lesson, we talked about conduction, convection, and radiation. Okay, the three methods of heat transfer. And I said there's probably going to be a practical application type of question on there. So I might ask you to design a structure that could keep something hot or cold, or I might show you a structure that is designed to do that, and you have to evaluate it. Why does it work? Does it work at all? Okay, what is it doing to prevent conduction? What is it doing to prevent convection and radiation? Okay, how is it keeping this thing warm or cold? Okay, something along those lines. There's going to be some sort of evaluation on your part being done, okay, of heat transfer of a device, okay, or structure. Everybody follow me there? Okay, so that's going to be, that's one of those higher level thinking questions. It's really easy to go, yeah, it's white, and so it would be hot or whatever, like something like that, but that's going to be like 1 or 2 out of 5, okay? But explaining and working in the words, the terminology, convection, conduction, radiation, maybe you work in albedo into there somehow, okay? All of that kind of stuff shows that you really have an in-depth understanding, so the more stuff that's applicable that you can work in, the better. Okay, and we talked about winds, okay, trade winds, Coriolis effect, okay, causing prevailing winds. That's something you certainly are going to need to be able to explain. We went over that in pretty great detail, right? When sunlight hits the Earth's surface, so here's the Earth and it hits the Earth's surface, hot air rises, okay, and then it starts to circulate and cool air moves in from below, and that happens 3 times in each hemisphere, okay? But as the Earth spins this way, underneath that air that's moving downwards, it appears to get deflected, and that's what causes it to seem like it's coming from different directions. We're actually moving through the atmosphere as the Earth turns. Okay. All right, so there could be a written response question asking about the prevailing winds and how they happen. Trade winds and Coriolis effect, this could be a written response as well, okay, explaining what the Coriolis effect is. Trade winds, that's those winds there at the equator. That might be like a multiple choice kind of question, because it's more recall. Okay, also remembering what the jet stream is and why the jet stream is important, especially if you get a question about energy transfer from the equator to more northerly areas. The jet stream is a big part of that, because it's that weird thing that can, if you got the Earth here, it can do this kind of weird patterns all over. It can dip down to the equator and pick up a bunch of warm, moist air and push it northward, okay, bringing in all that energy. So it's a special wind, okay, that helps with moving a lot of latent heat and large air masses. Okay, so are you sensing kind of a theme here? There's not a lot of stuff in this unit, so I'm expecting you to know it at a higher level. Okay, I'm expecting you to do more with the small amount of stuff that there is in this unit. Okay, everybody follow me there? Because I mean, it'll be easy to remember everything in this unit. There's not that much there to remember. Okay, but can you tell me how well you can apply it? Okay, that's going to be the big thing. Okay, and then we went to heat capacity, okay, energy absorption and temperature change using the formula E equals mc delta T, right? There'll be a problem in the written response that asks you an E equals mc delta T question, and obviously we also use it in the latent heat heating curve questions as well. Anywhere where the line is going up, we use that formula as well. Okay, and again on the test, you'll either be given the specific heat capacities in the question, or I'll give you a chart on the front. I think it's actually a little bit of both. I have some on the front on the information sheet, and then in some of the questions I give you more if you need them. Okay, so certainly there'll be problem solving on that. Could there be multiple choice questions about what heat capacity and specific heat capacity are? Maybe what their units are. Okay, remember that heat capacity is joules per gram degree Celsius. Okay, how much energy is required to heat 1 gram by 1 degree? Okay, Bridget? It's the same formula. Yeah, some people use Q, some people use E. It's the same thing. I'm not sure why they go with, some people go with Q. We try and keep it consistent and always have E represent energy, but sometimes in certain chemistry classes they'll use Q for whatever reason. It's still the same formula. Okay. Okay, and then latent heat, okay, we talked about what it is, okay, and we've said several times it's really a big deal in terms of moving heat energy, thermal energy from the equator to more northerly parts of the world, okay? It's the energy that's used or given off when a state change occurs. If I want to melt ice, I've got to put energy in, but when water freezes, energy is given off, and the same thing goes when water evaporates, energy is used, but when steam condenses back to water, energy is given off, okay? That's latent heat. Latent heat diffusion is involved in melting or freezing, okay? That's LF. And what's LF for water? Anybody remember? Because we tried to figure it out at the end of the day yesterday. 333, okay? Joules per gram. That means every gram of ice requires 333 joules to melt, okay, as long as it's already at 0 degrees. Okay, and then the latent heat of vaporization, okay, that has to do with evaporation, vaporization, or condensation, and that's LV, and that one's 2,260 joules per gram, but again, those numbers will be given to you on the front of the test, okay, so you don't have to memorize them. Okay, and then we talked about here, the heating curve of water. Okay, so if we're down here, what state is the water in down here? It's frozen. So this is ice. Okay, remember that when we're using E equals mc delta T here, we have to use the C for ice. Okay, we have to use whatever substance it is, we got to use the right specific heat capacity. Okay, and then here, what's the ice doing? It's melting here. Okay, so we'll have the mass of the ice and then multiplied by the latent heat diffusion. Here, at the end of this step, I no longer have ice, I now have water at 0 degrees. This is showing what happening to the water. Warming up, right. I'm increasing its temperature. That's why I would use E equals mc delta T here. And what C do I use here? I use the one for water, 4.2. Okay, and then on this part here, I start with water at 100 degrees that's boiling, and I finish with steam at 100 degrees. Okay, so I use this formula here because there's no temperature change during this time, m times LV, and then at the end, I've got steam, and I'm heating the steam, so I'm back to mc delta T, except I'm using the C for steam now, 2.02, okay, to figure that one out. All right, guarantee there's one of those on the test. Right, and it's worth 8 marks. 3 steps. Okay. All right, questions on that part? Okay, you guys seemed pretty good at those in class, so it's not too much to worry about. Okay, and then biomes, you got to be able to identify them. I give you a picture and a description in the multiple choice. You've got to be able to match it up with the right biome. And of course, back to the climatograms. If I give you a climatogram, you've got to match it to the biome and explain. Yep. No, what I would do is when you're reading through those biome notes, and maybe you'll want to do that today while you're doing your review, is as you're reading through, highlight a couple of things that are really unique to that biome, because that's what I'm going to use, right? When I'm writing a description, I want to pick the things that are most specific to that biome so that you pick the right one, right? So if you're looking at it and go, you know, if you're reading through the savanna, for example, the monsoons, having that period of rain and then long drought, that's a key characteristic. No other biome that we talked about has that, okay? So that would be one of the things that I would highlight as an identifying feature, okay? Really long grasses in tropical climate would be another one for the savanna, because other places that are tropical are rainforests or deserts, okay? So these would be things that are very unique to that. Does everyone follow me there? Okay, because yeah, if you're trying to memorize everything about every biome, it's a lot of information. Just highlight the stuff that's specific to that biome, okay? And then that'll be the stuff that you'll probably find, right? Remember, you only have to recognize this biome, okay? I'm giving you the description and a picture. I mean, the picture makes it pretty easy, okay? In fact, you could probably figure it out from the picture. You'd want to double check. Obviously, don't just look at the picture and then pick. Okay, read the description too, but the pictures are pretty much a dead giveaway. Okay. Hey, other questions? Okay, anything? Okay, Danny? I'll have to look it up. Give me a second. Okay, so with all the pictures that are going to be on this test, and then of course I opened the wrong thing. Okay, you might want to look at on my website the actual notes. Okay. So if you go into like global systems here and you open up lesson 1, okay, it actually shows all the pictures that I had, okay, whereas your notes don't always have all of the pictures, okay, so it's not a bad idea to look through those just to get the visuals. I mean, you already have all the text that's there, okay, but sometimes there's more pictures in there. Yep, the front page has all that on. It won't have the heating curve. No, you have to remember that shape on your own. No, that was just an example of an ocean current. Ocean currents in general work the same. Okay, other questions there, guys? Anything you want me to recover on the review package? Yeah. Kicks up. Okay, so describe the 4 major components of climate as they exist in Okotoks. So what I would do for that, okay, would be then I would just list them first. I would say, you know, like temperature, okay, precipitation, light, winds. Okay, and then I just would describe each one. So I would say temperature, okay, would be variable or fluctuates, okay. That's supposed to be an A, fluctuates, okay. You know, winters are cold, okay, things like that. Summers are hot. Winter's cold, summer hot, okay. I would maybe mention that it's temperate, okay. It's not extreme at any point during the year. I mean, sometimes we feel like the cold is extreme, but it's not. Okay, sometimes we feel like the heat is extreme, but really it's not. Okay, very rarely does it get into areas where we have to worry. So I would say temperate. That would be, you know, a decent description of that component. For precipitation, I would say relatively dry, with the bulk of the precipitation coming in like late spring, early summer. Okay, so that would be like June. right? Then light, I would also say variable or fluctuates, and I would also say that it's indirect most of the year because of the high latitude. Okay, and then for wind, prevailing winds are from the southwest. Chinooks are a big part of this biome. Southwesterly warm winds, things like that. There's the four components, and I've described what they're like here. Yeah. Okay. Other questions? Okay. So you can work on that review sheet or do whatever other review activities you want to do. If there are questions, just ask and I'll go over them. Hunter. Number 12. Yeah, this is exactly what I told you I was going to ask, right? Design and build a structure that could keep frozen foods cool in the middle of the California desert. What do I want to do with all the light that's coming in if I want to keep things cool? I want to make it reflective. What color should I make this? White, right? Okay. Do I need to insulate it? How am I going to do that? Okay, I need to prevent convection, right? That's what I got to do. If I want to insulate, I got to prevent convection. So I would want either, like fiberglass insulation, or we talked about how lots of thermos mugs and things have a vacuum inside. If you could make a vacuum between the inside and outside walls, that would not only prevent convection, but it would also prevent leaks, yeah, or conduction too, right? If the solid parts aren't touching, then there's no conduction. And you actually do notice that on these cups, like everywhere in through this part, it's actually quite cool to the touch. But where the lid makes contact, okay, and there's less insulation, it's actually warmer there. Same at some of the seams, it's warmer there because there is conduction that's happening through the metal. Okay, so we want to eliminate as many contact points as we can, or insulate the contact points as much as possible. So basically, you have to tell me about conduction, convection, radiation, and how you're going to prevent. You got it, Hunter? You're not even looking at me anymore. Yeah. Okay. All right. Everybody with me there? Okay. Other questions? Okay. Well, as more come up, okay, Brid. Temperature, precipitation, light, and wind. Those are the four components of climate. No, I wouldn't mention the jet stream when I'm talking about the components of climate that affect Okotoks. Because, I mean, the jet stream is variable, right? Sometimes it's passing over us, sometimes it's nowhere close to us. I mean, it moves air masses, but it's not something that we can count on all the time. It's not a steady thing, right? Okay, we'll keep working, and if more comes up, just ask.